Okay, this video will be about osseous tissue. We're going to start with histology. So that means what we see under the microscope. In our previous video, we talked about bone being a connective tissue. Well, you know that connective tissue has to have cells and fibers and also that matrix or ground substance. Bone is not so bad because there's only 4 types of cells, except that they all sound so much the same, so it gets a little confusing. So make sure that you've got a way to remember them. You'll definitely see an essay question on a quiz about this. So osteogenic, osteoblasts, osteocytes, and osteoclasts. Here we go. So osteogenic cells are stem cells that are found in the endosteum, periosteum, and in the central canals. So they are what are multiplying, and then they will be producing new osteoblasts. Okay, so if you want to think about, I don't know how you're going to remember this, osteogenic stem, that doesn't really rhyme, but they are the cells that will produce osteoblast. Okay, osteoblasts are bone-forming cells. Okay, so they make a single non-mitotic layer of cells, so not dividing, under the endosteum and the periosteum. And they help synthesize the organic matter of the matrix, which then hardens by mineral deposition. And we'll talk about deposition and resorption in a separate video. So for now, just be memorizing how you're going to remember each type of these cells, and then their functions are going to make sense a little later. Stress and fractures stimulate osteogenic cells to multiply more rapidly and to make more osteocytes, to reinforce or rebuild a bone at a site of a fracture. And then they also secrete osteocalcin, which we previously thought to be the only structural protein of the bone, but also stimulates insulin secretion of the pancreas and increases insulin sensitivity in adipocytes, which limits the growth of adipose tissue. Remember, that's fat tissue. Osteocytes, to me, that's the mature bone cell. So cyte means cell. That one's easy for me to remember. That's a former osteoblast that have become trapped in the matrix that they have been deposited. So I remember osteocytes as the mature bone cell, and maybe you could remember osteoblast. B comes before C, so the osteoblast comes before the osteocyte. We'll see osteocytes are in a little cavity. It's called a lacuna. I've never heard it called a lake before, but a cavity is fine. And then there's channels or canals that connect the lacuna to each other called canaliculi, which is one of my least favorite words in anatomy. And then there's little cytoplasmic processes that extend into those canals from the osteocytes. So again, we'll get into physiology in the next few videos, but some osteocytes reabsorb bone matrix, okay? And later you're gonna see the term resorption. So reabsorb and resorb mean the same thing, and then others deposit it. Again, we'll get more in depth later, but that contributes to the homeostasis of bone density and also the concentration of calcium and phosphate ions. So there's times that calcium ions need to be reabsorbed, and there's other times that they need to be deposited. So when stressed, they produce biochemical signals that regulate bone remodeling. Again, we'll have a whole separate video on this. Okay, osteoclasts are bone-dissolving cells. Now, I feel like this is hard because you want to think that osteoblasts are dissolving. Think about a blast breaking apart something. But so this is opposite of what you would think. Osteoclast is bone-dissolving cells found on the bone's surface. So they are breaking apart bone cells. They do develop from the same stem cells that give rise to blood cells, and they have a different origin other than from the other bone cells, which makes sense because they're setting out to destroy them. So it makes sense that they would come from a different place. They are unusually large cells, and they come from the fusion of more than one stem cell. So they usually have 3 to 4 nuclei, but some can have up to 50. really picky about any of this. We'll talk more about function in later videos, so I think we'll get to all of that. Okay, the matrix of the osseous tissue or the bone tissue is dry weight, but it is 1/3 organic and 2/3 inorganic matter. So let's clarify what that means. Organic matter is synthesized by the osteoblasts, so it's comprised of collagen, carbohydrate, and protein complexes. And inorganic matter is calcium phosphate salt, calcium carbonate, and then other minerals. So usually organic means that it has carbon, and then inorganic is anything that doesn't involve carbon. So bone is a composite, which means it has a combination of two materials, ceramic and a polymer. The polymer, the protein, gives the bone some degree of flexibility, whereas the ceramic allows the bone to support the body weight. We'll get into bone disorders towards a separate video, but we will talk about rickets and osteogenesis imperfecta, which is brittle bone. And so brittle bone has a lack of that protein, collagen, and then rickets has deficiency of calcium salts, so not enough calcium salts lead to soft bones. Okay, so here is what we're going to see in the lab. So that figure 7.5a is just showing you a long bone cross-section, and then 7.5d is what you'll see under the microscope, which you already saw under histology, but I think you're going to probably take a closer look at it. So those are the comparison between the spongy and the compact bone, and then we'll also see the lacuna and those little canals in the central canal. To me, it looks like a dartboard, and that's kind of how I remember all of those little layers. So there's a basic structural unit of compact bone, and that is called the osteon. I like osteon way better than Haversian system. We'll talk about the word Haversian later, but osteon makes more sense to me. That's basically one unit, structural unit, and that is made of the central canal, and then those lamella that are around it, and then the lamella are connected to each other by those little canals. So there's basically a cylinder of tissue around that central canal. So as I said on the previous slide, it reminds me of a dartboard. Well, that bullseye is the central canal, and then around that is the lamellae. Then we will see transverse or diagonal passageways that run along the length of the osteon are called the Volkmann canals or the perforating canals. So they're running parallel to the central canal. No, perpendicular, I'm sorry. Perpendicular to the central canal. And then we'll also see, actually I don't know that you're going to be able to see this, but there's collagen fibers that corkscrew down the matrix of the lamella, making it look like a kind of a helix. So the skeleton receives about 1/2 liter of blood per minute. Much blood is lost into a fracture. We said that there's these little, I don't know, I was going to say dimples, little entrances for the blood vessels and nerves to enter the bone called nutrient foramina, and they connect those perforating canals across the matrix, and so that allows the blood vessels to reach and the blood to go throughout the bone, and they connect to the central canals. So the innermost osteocytes near that central canal receive the nutrients and then pass them along through gap junctions to the neighboring cells. They also receive waste from the neighboring cells and transfer it to the central canal, which is keeping a two-way flow of nutrients and waste throughout the bone. But not all of the matrix is organized in osteons. There's some other lamellae, inner and outer boundaries of dense bone that run parallel to the surface. And then there's some remains of old osteons that are deteriorated as the bone grew. So, but for the most part, the bone is arranged in osteons. So this is an up-close picture of kind of what the layout of those blood vessels within the bone are, and you can see those central canals and then the Volkmann canals that cut across, transverse or diagonal canals. I think think that's all from here. So the central canal and then those Volkmann's canals that adjoin them.